Hey physics, here's the dimensional analysis big ideas. So this unit is all about converting units, meaning that we're going to use conversion factors to convert one unit to another. So for example, we can find out how many feet are in 5 miles, or how many tablespoons are in 1 cup, or what's 2.5 meters in feet. And we're going to do that by looking at basically a fraction that means that stands for like the number 1, right? So something like, I always like to think of like 12 inches equals 1 foot, right? So we can think of it like 12 inches over 1 foot. Or we could think about it like 1 foot over 12 inches. Either one of those means the same thing, and they both mean the number 1. So what's cool about that is it allows us to change the units, which is like a word, right? Like meters or feet or hours or minutes. Convert one of those things to another without changing the value of the numbers, right? They might have different words attached to them, but they're the same numbers. So how do we do that? So let's think about an example of, like, if we want to throw a pizza party for 30 students, and we want to make sure we have at least 1 slice of pizza for each student. Obviously, we're going to need 30 slices of pizza. And we know that 1 pizza has 12 slices in it. So to do that, we can say we want to know if 4 pizzas is going to give us enough slices for 30 students. So if I know that there's 12 slices in 1 pizza, then what I can do is I can say 4 pizzas. I have 4 pizzas, and I'm going to put that over the number 1. And then I know that there's 12 slices per pizza, and so that's going to give me 48 slices of pizza, because the strategy here is that we put our units that we're trying to get rid of on opposite sides of the vinculum. The vinculum is this little line that divides the fraction there. So I've got pizza on the top, pizza on the bottom. That's going to cancel out pizza and leave me with slices. So I'm going to multiply across the top, then multiply across the bottom, and that will give me my answer. So 4 times 12 is 48. 1 times 1 is 1. So 4 pizzas with 12 slices each is going to give me 48 slices of pizza. Plenty for 30 kids. I hope. I always feel like I need like 4 or 5 slices of pizza. Let's see. So yeah, so this is what this looks like. So we've got 1 pizza is 12 slices, or 12 slices is 1 pizza. Both of these equal the number 1, and that's why this works, because again, we're not changing the value that's there. We're just changing the units that are attached to it, canceling them out by putting them on the opposite side of the vinculum. Okay? 4 pizzas. Pizzas cancel out, and it's really useful to use these canceler outers, which is really just a line. I can go up here and say line, and that will give me a line to cancel out with. And then using a circle to show me that that's the unit that I want to keep. So shapes, circle, and that's really useful for that. So pizza is taken care of, and now I'm left with slices, 48 slices. Okay, so let's do some practice problems about this. So in any of these problems that you're going to see on the test, there's always going to be a conversion table. Also, the same thing works if you Google like how many yards are in 1 mile, or how many quarts are in 1 liter, or how many hours are in 1 minute, that kind of thing. You can always find that out there, but we'll have a conversion table for you. So any one of these can be turned into a conversion factor, meaning you could do 1 mile over 1,760 yards. And again, another part of this unit is looking at these big numbers, or these numbers with a lot of decimal points after them, and thinking about, like, how do we say that, right? So 1 mile is equal to 1,760 yards. You can write that either 1 mile over 1,760 yards, or you can do 1,760 yards over 1 mile. The important thing is always that you include the units in there so you can cross them off and make sure you can keep track of everything. So, a runner completed a 5-mile run. How many yards did she run? Okay, so we know that 1 mile is equal to 17, and you can also think about it like 1760, because to me that's easier to break it up like that. And that 100 means there's like two places there, 1760 yards. You can write it like this, or you can write it like this. So we're starting with 5 miles, and we want to get rid of miles and go to yards. So cross off miles, because we put them on opposite sides of the vinculum, and then we put yards up top here. So we arrange that conversion factor so that the yards, the one we want to have, is not going to be canceled out, obviously. It's on the top. And then we multiply across the top. So 5 miles times 1760 yards is going to be 8,800 yards. Okay, multiply across the top to get that number. We could also multiply across the bottom. 1 times 1 is going to be 1. So that would be 8,800 yards over 1 is what that ends up being. So you finish off a nice meal with a nice slice of pound cake. Pound cake is named because it weighs a pound. It's like that thick. What would the name of this cake in ounces be? So 16 ounces is the same as 1 pound. So if we want to get rid of pounds and go to ounces, we could use a conversion factor that looks like this, 16 ounces over 1 pound. Or we could use a conversion factor that looks like this, 1 pound over 16 ounces. So we're trying to get from 1 pound to 16 ounces, so 1 pound. And I'm going to choose the one that's going to put pound on the opposite side of the vinculum as where I started. So pound is on the top here. I'm going to put it on the bottom here. So 16 ounces is on the top. Cancel out pounds. Stuck with ounces. 1 times 16 is going to be 16 ounces. And then 1 times 1 is 1. I don't remember if I said these yet, but it's really important to have that 1 underneath your very first thing. Unless you have, like, if you're converting 2 units at the same time, then you would just have those 2 there. But if you're converting just 1 unit, put it over 1, because that doesn't change its value at all. It's just saying like 1 Mrs. Allen divided by 1 means there's just 1 of me, right? If I did Mrs. Allen divided by 2, that would mean there's like 2 halves of me. But anything divided by 1 is just the same thing as itself. And that holds your place. That makes it so that like you can see that vinculum on each one and cancel it out nicely like that. Okay? So, last practice problem for the big ideas. In the Tour de France, cyclists ride 3,653.6 kilometers in 20 days. How many miles do they ride? Okay, so we're going from kilometers to miles. And if we want to get fancy about this, and maybe I'll start the practice problems with this, we could do kilometers per day, and we could go to like miles per hour or something like that. So maybe I'll start the practice problems with that. Okay, so 1 mile is 1.6093. Now, I see that goes really detailed. If you want to make it just 1.6 kilometers, that's okay, because that's a lot of detail there. 1.6 kilometers is fine. 1 mile is equal to 1.6 kilometers. And the same thing is that 1.6 kilometers is equal to 1 mile. These are a 1-to-1 ratio. Okay, so if I'm trying to go from kilometers to miles, then I'm going to put kilometers on the bottom, and I'm going to put miles on the top. So, and then I'm going to multiply across the top and get that number. So 3,653.6 times 1 is going to be 3,653.6. And then I'm going to divide that by 1 times 1.6. Okay, so what that's going to end up being is 3,653.6 kilometer, or 353.6 divided by 1.6. And that's going to give me that 2,270.3 miles. Okay, so Yeah, let's start some practice problems. You ready for this? I just want to say one last thing that with a lot of these problems, you might have to do two layers, right? Like in your dimensional analysis project, you had to convert like kilometers per hour to miles per second or meters per second or something like that. So when you need to convert that bottom unit also, then instead of, it still is going to go across the vinculum, but you might have to do like, this would be like kilometers in 20 days down here. So you'd have to put days down here, cancel it out here. So days and days on a separate conversion factor. And then the thing you're going to keep is going to be down there. So I think I'll make a second video for you with a couple of dual unit conversion factors, and we'll start the practice problems there. Okay? See you soon.